Today we're going to discuss writing equations in slope-intercept form. So your essential question is, given the graph of a linear function, how can you write an equation of the line? So we've kind of practiced this in our exploration earlier, but we're going to kind of continue with this and try some different kinds of examples. So first it says, write an equation of each line with the given slope and y-intercept. So keep in mind, we're writing equations in slope-intercept form. So first, what is slope-intercept form? So slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. And remember, the y-intercept is the point where it crosses the y-axis. So, if we're plugging this information into our equation y equals mx plus b, then for this one, we would have y equals, and our slope, m, is -3, so we would have -3x, and then plus our y-intercept, which would be 1/2. Okay, now this one, we have a slope of 0. So if I were to plug that in, y equals 0x, and then plus -2 or -2, then how many x's are in my equation? There are 0. So if there are 0 amounts of x's, then really you don't need this part at all. So you could just write y equals -2, and that would be the same thing. So if you're given the slope and the y-intercept, then you can just plug those numbers right into the formula. Okay, so it says write an equation of a line in slope-intercept form. So we're doing this for each graph. Okay, so again, the information that we need is the slope and the y-intercept. So how do we get slope? What is slope represented by? So the slope is like the steepness of the line. And so remember, slope is equal to the rise over the run. So if I want to find the rise of my line, I'm going from left to right. I'm figuring out how much I rise versus how much I run. So I would rise on this one 1, 2, 3, 4, 5, 6 spaces, and I would run 1, 2, 3, 4 spaces. So m, my slope, would be 6/4. Now that can be reduced. What can I divide both of those numbers by? They can both be divided by 2. So 6 divided by 2 is 3. And 4 divided by 2 is 2. So our slope is 3/2. Now I also need b, the y-intercept, so that I can write my equation. So where does my line cross the y-axis? Well, it crosses right here at -3. So on this one, b would equal -3. So now I can go ahead and I can write my equation of my line. Remember, it has to be in y equals mx plus b form. That's slope-intercept form. So my equation would be y equals, and then I have m, my slope, which is 3/2 x, plus b, which is -3. So you can put plus -3, or you can put -3, since it's negative. And that would be your equation for part A. Now for part B, what do you notice about the slope of this line? Is it positive, negative, 0, or undefined? So it looks to me like it's going downhill, so our slope is negative. So when I rise, my rise is going to be going downward. So I'm going to go down 1, 2, 3 spaces, so that's -3. And then I'm going to run 1, 2, 3, 4 spaces. So on this one, my slope is -3/4. And my y-intercept is right here at 2. So b equals 2. So the equation of my line, if I plug those numbers into my y equals mx plus b, would be y equals negative 3/4 x plus 2. All right, now we're going to get a little bit more difficult. We're going to get some examples that we haven't quite seen before. So write an equation of the line that passes through the points 0, -2, and 4, 10. So if you're thinking about this, think about what information you need in order to write the equation of your line, just like we did on the previous problems. And then think about two different ways that you can get that information. So first we know that we need to find the slope. And there are two ways that we know about for finding slope. One way would be by graphing. So I could graph these points if I wanted. Or the other way would be by the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I could plot these points on a graph if I wanted to. I'm going to go ahead and do that really quick. So I can pull the graph here for a minute. So if I was graphing these points, 0, -2, and positive 4, 10, and I would have a really big, steep slope between these points. Okay? So I could count the rise over the run. Or I can just use my formula. So this would be like x1, y1, and x2, y2. And so I would do y sub 2, so 10 minus a -2 over 4 minus 0. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 10 minus a -2, that turns into addition. So I get 12 over 4. And if I take 12 divided by 4, I just get 3. So my slope, my m, equals 3. And then I need to know my y-intercept. Well, we got kind of lucky this time. And one of our points that we were given is actually our y-intercept. So if you're looking at this, and you look at your y-axis, your y-intercept is this point right here. It's on the y-axis. It's -2. So b equals -2. Okay, but let's say that we didn't graph this, and so we didn't recognize that yet. So for part 2 of how to write our equation, for part 2, we're going to identify the y-intercept. Now we already found it. It's right here. Okay, if you graphed it. But if you don't graph it, remember your equation has to look like y equals mx plus b. Well, I have all of that information. I have an x-coordinate and a y-coordinate, and I have the slope, and I just need to find b. So I could take any of my points and use them as my x and my y. So in this case, this would be y and this would be x. So 10 would be plugged in for y. And then m is 3. That's my slope. and then x is 4, and then I don't know b. So if I continue to work this out, what is 3 times 4? Well, we would have 12. And then if I want to get b by itself, then I just subtract 12 from both sides. So I get b equals -2. So if either way, if you graph it or if you use this equation to help you find it, you can get your y-intercept. Now the reason why this is helpful to know is because if I had points like 35, 100, and 24, 17, then I would not really want to graph those. It would be difficult for me. So it would be easier just to do it algebraically like this. So that's why you need to know how to use the formula for slope and how to use the equation for slope-intercept form to find out what's missing. Okay, so now we can go ahead and write our equation. So step 3 would be to write the equation. And again, it's going to look like y equals mx plus b. So if I have y equals mx plus b, okay, then I get y equals m, which is my slope, which is 3x, and then my intercept is -2, so I could put -2. Now you could have gotten that from the very beginning, but I wanted to let you guys know how to use this formula in case you come up with some that aren't so lucky where the y-intercept is not given to you. Okay, now I'm going to clear all of this out so we have some room to work out the next problem. Okay, we'll go ahead and delete that. Oops. Okay. So on this next problem, it says write a linear function g, so we're going back to functions, with the values g sub 0 equals 9, or I'm sorry, g of 0 equals 9, and g of 8 equals 7. So remember, we're talking about functions again. So like I'm plugging in inputs and outputs. So if I'm looking at my first one, this is function g. Okay, so I'm taking 0 and I'm plugging it into my function g. So if I make a list of my inputs versus my outputs for my function, when I input 0 into g, what do I get? Well, I get 9. And then when I put 8 into my function g as my input, what do I get as my output? I get 7. Now, inputs and outputs are just different ways to represent what things? Well, these are how we represent x as our inputs and y as our outputs generally. So, really, I just have two coordinates again. I have the point 0, 9, and I have the point 8, 7. So again, if we follow our 3 steps, first we need to find the slope. We can do that by graphing or by using the formula. Since we don't have a graph right here handy, we're just going to use the formula. Okay, so for slope, I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this would be x1, y1, and x2, y2. So I'm taking 7 minus 9. And I'm taking 8 minus 0. And if I work that out, I would get -2 over 8, which can be reduced. We should always, always, always reduce. So what number can both of these be divided by? Well, they can both be divided by 2. So if I take this divided by 2, I get -1. And 8 divided by 2 would be 4. So my slope is -1/4. That's my m. Okay? Then I'm going to find my y-intercept. And I can do that by using my equation, y equals mx plus b, and plugging in all the information. But if you notice something, look at your points that you were given with in the beginning. Where does the point 0, 9 fall on a graph? Well, it falls on the y-axis. So my intercept is actually 9. If I was to graph this point 0, 9, it would be on the y-axis. So my equation then would be y equals mx, so I have negative 1/4 x plus b, which is 9. And I am all done. Alright, one more word problem. So it says the corresponding data for electricity generated by hydropower are 248 million megawatt hours in 2007 and 277 million megawatt hours in 2012. Write a linear model that represents the number of megawatt hours generated by hydropower as a function of the number of years since 2007. So this is like overload of information. Just crazy stuff going on here. So we need to kind of highlight what information is important. Okay? So we know that it says blah, 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 blah. We have some numbers here. 248. All right, 248 in 2007 and 277 in 2012. And then it tells us to do some stuff. So let's see what it says to do. So we're going to deconstruct this just a little bit. So it says write a linear model that represents the number of megawatt hours generated by hydropower as a function of the number of years since 2007. So number of years since 2007. So after 2007. So how many years after 2007 is the year 2007? Well, it's the same year, so that would be 0 years after. They had how many million megawatt hours? They had 277. So 0 goes with 277. Those are like coordinates for us. That's like an input and an output, an x and a y. It's a function. Okay? Function. Input, output. Okay? So then what would be the input, output for, I'm sorry, I had the wrong one. 248 was the first one. Let's go back and fix that. 248. Okay, 248 in 2007. Okay, then I had 277 million in 2012. Well, how many years since 2007 was the year 2012? Well, let me go 7, 8, 9, 10, 11, 12. That would be 5. So we would have 5 years since 2007. And then we had 277 million. So here we have our 2 points again. And we are writing a linear model, which is the same thing as the equation of a line. So I need 2 things. I need my slope, m, and I need my y-intercept, b. Okay, and then I can write my equation. So to find the slope, I'm going to do the same thing. I'm going to use my formula. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So remember, I have x1, y1, x2, y2. So I have 277 minus 248 over 5 minus 0. So we're going to take 277 minus 248. So that would be 29. And then we have 5 minus 0, which is 5. Now, unfortunately, this cannot be reduced, but you can turn it into a mixed number, but we don't really like mixed numbers. We want our slope to be in rise over run format, so we're just going to leave it as an improper fraction. So that's our m. That's our slope. Okay. Then we need to find the y-intercept. Oh my goodness. I noticed right here that if I were to graph that point, the point 0, 248 would still be on the y-axis. So what would be my y-intercept? It would be 248. So b equals 248. So then what would be the equation of my line or my linear model? I would have y equals mx plus b. So y equals 29 over 5x and then plus 248. Now, you would have to note in your function that this is given in million megawatt hours. Otherwise, you would have to write million after these numbers. But just for these purposes, we will know that it is represented in millions since it's consistent. So this would be the correct answer. All right. Make sure to go back and answer the essential question to write your summary, and also list your 2 potential test questions. Thank you.